Okay, with that, I'll pass you over to the presenters. We've got, as you can see, a large group. Robert is up first. Robert, I'll pass it over to you.
All right, thanks, Thomas. And I'm going to go ahead and end the poll. Thank you very much for taking the poll. And sure, I'll share the results with you. Okay, just so you can also understand the other folks that are in the audience with you. You know, there's quite a few people who are familiar with Autonomous Database, but less people with Exadata and even less with observability and the overall observability and management platform, which is great in a sense that we're gonna talk a lot about that stuff today. So you should find this educational, which I think is great. Let's see. Let me close this down. Share my screen real quick. Okay. All right. So what I have. So I've got a bunch of people with me here today. So thank you for your time and spending it with us to learn about advanced customer deployments today with Autonomous Database. And I have here with me today a number of specialists. I have Viscuso, who's my director of community management, and myself. I lead product management for the Autonomous Database on dedicated infrastructure. And then I have a couple of Autonomous Database technical specialists with me here who are going to do the demo side of things today, Quentin, Jansen, and Alastair, Newson. And then also we've got a specialist with us from our observability management platform, Rishabh, from our cloud team. And so this is going to be a packed agenda, and let's just jump right into it. So we are going to focus on Autonomous Database on a dedicated infrastructure today. So you can get the Autonomous on a completely serverless platform, but you also can get it with dedicated infrastructure, which is also the form factor that comes in what we call Cloud at Customer, where you can actually run Autonomous Database inside your own data center on dedicated infrastructures. We're going to talk about some of the advanced features that we've released very recently. In particular, our VM and VM subsetting capabilities, review some of the advanced customer architectures that are deployed and in practice to give you an idea of what people are doing with the service. And then we're going to spend quite a bit of time talking about observability and we're going to do demos kind of intermixed throughout all this topic to give you an idea of what, Autonomous Database is all about. It's just a lot of stuff that we're going to cover. And we're going to focus, though, on the dedicated and Cloud at Customer oriented deployments. Okay. So in the Oracle Cloud, there's a large spectrum of databases, database services that you have available to you. And for the dollar that you spend on a core inside Oracle Cloud for these database services, you get more value as you move towards the autonomous spectrum. So if you move off the regular VM-based databases to Exadata, you get a much more performance Exadata-oriented architecture, which is kind of a distributed architecture where you send the processing actually down into storage tiers, almost like a Hadoop-like architecture, and it really accelerates and improves performance for very, very large scale database deployments. And also it has all of our maximum availability just built into it. Okay. And then as you move towards autonomous, you get where you delegate to Oracle experts and our automation layers, operations of the database. And so that's where you really get the most value, because you're basically moving to a fully managed service with autonomous. And today we're going to focus on, that autonomous in a dedicated infrastructure deployment or a Cloud at Customer. Okay, so fully managed Oracle database services in those form factors. Okay, and so as I mentioned, you can get a serverless deployment for Autonomous Database, but in dedicated, it's actually more than just like a dedicated hardware, right? I mean, that's the obvious thing, but also with this dedicated environment, you get more control. You get more control over isolation, and you get more control to put policies in place so that our software automation layers are basically following your guidance in terms of how it is that we operate the database. So you can start to control things like the specific software version that you're running and exactly when the maintenance schedules are going to happen. And you can set up a kind of governance environment in terms of how it is that you roll your software updates and all that through these different environments. And so dedicated obviously is what you get with Cloud@Customer, because clearly it's sitting in your data center and it's dedicated to a single tenant. Okay. So when you look at the autonomous database resource model, in serverless, you just have the autonomous database, okay? And all the underlying layers are abstracted away from you, okay? But in the dedicated model, you get access to an infrastructure. So there's an API to spin up infrastructures, and there's an API to then on an infrastructure, which can be large. It can be, 32 compute hosts, 64 storage cells that will support petabytes of data. And you can, in that environment, you can deploy VMs and you can isolate different project teams, different databases, what have you, to different VMs within an infrastructure. And then within those VMs, you can allocate containers where you're actually going to run the autonomous database. And in those containers, you can set the SLA. So, one of them can be a normal clustered deployment. One of them can be, replicated across availability domains or across regions to give increased SLAs for sort of site level events. So you've got these additional resources in the dedicated / Cloud@Customer model that you don't have in the serverless model. Okay. And so one of the key things that we offer is, again, this VM and VM node subsetting. So even though one of these infrastructures might be quite large, you can take a VM and you can say, hey, I'm going to run a VM on a particular set of hosts within that system. And yeah, if you want a very large one, which, for like a super large mission critical database, you can have a VM that spans the entire infrastructure, right? Spans all hosts in that infrastructure. But if you've got smaller project teams, you can sort of spin them up on a minimum of 2 hosts for availability reasons. But you can spin them up on n number of hosts within that infrastructure. Okay, and using this model, you can control and isolate. I mean, if you wanted to, and some customers do, you can put one database on one infrastructure, right? You can control the isolation at that level, or you could control it, with different VMs, different containers in those VMs, and you can set it up in such a way that you drive like all changes through, for example, a dev test environment, okay? Where any kind of app code changes, stress test, configuration kind of changes, or database patches, infrastructure updates for security reasons, all that gets driven through one layer. And then, maybe 30 days or, even 90 days, a quarter later, you would end up, for policy, having that stuff roll through to your UAT. Okay. So after you've really sort of done your stress testing in dev, and then it can sit in UAT and bake for as long as you want, for 30 days, 60 days before it finally rolls through to your production environment. So you can set up this governance model where even though we're operating and you've delegated that to Oracle, you actually have some ability to control so that any changes basically roll through a very robust governance process before it hits your production systems. And so you can sort of trust and verify the autonomous operations. And so if you've never seen this, if you've never seen autonomous database in action, we're going to start off with a demo so that you can see all these resources and the control that you have. And I'm going to pass it over to our specialist, Quentin Jansen, who's going to walk you through it. So Quentin, take it over.
Thanks a lot, Robert. So I'm just going to quickly show you how we set up the infrastructure that Robert has just talked through. So I saw from the poll that most of you are actually quite familiar with autonomous database. So therefore, you're probably quite familiar with the OCI console as well. So I'll jump straight into it. With autonomous database on dedicated, once you look at the console, you'll see it's very similar to autonomous for serverless, except that we're now interested in some of the extra feet or the extra infrastructure that we set up on the side here. Exadata infrastructure is already provisioned, so what we're interested in looking at today is actually creating the autonomous dedicated VM cluster and the features that Robert has talked through, like the maintenance and also the node subsetting. When you do this, you'll go into the create, you'll select your infrastructure that you're going to be deploying onto. And once you've done that, you'll see that there's a few parameters that we need here. The first one that we're interested in is the charge model, so eCPU. You'll be familiar with OCPUs, eCPUs. eCPUs are now the default that we use for provisioning the infrastructure. And then editing the DB server selection. So this is the part where Robert had talked through node subsetting, where if you have more than 2 compute nodes on your rack, you can now choose which of those compute nodes you want to deploy your VM cluster onto. So in my case, I only have 2 compute nodes, so I have to choose both of them there. And then you have parameters underneath here. So the number of eCPUs that you want to allocate to this VM, the number of container databases that you want to put onto the VM, the memory per CPU. So in this case, with Autonomous Dedicated, depending on the workload, you can actually allocate more memory or less memory than what you have in serverless. In serverless, we're fixed with 16 gigs. With the Autonomous Dedicated, you can change that and you actually set it up within the VM, and then the storage allocated. On the right-hand side, you will see a summary of the resources that will be allocated to this VM once you create it. Next few things you need will be normal things. If you're familiar with base database, it's just the network that you want to be deploying into, the subnet. And then the next thing that we need to provide is the maintenance. So Robert had talked through with Dedicated, you have a lot more choice on when you want your maintenance to happen. Not the same with serverless. So in here, you can either have no preference or you can specify a schedule, and you can see from the schedule, it can be quite granular down to a specific hour on a day within a specific week and whichever month that you want to. So I'm going to leave mine with no preference. License included, or bring your own license, which you'll be familiar with if you're with Autonomous Database. And then at the bottom, we have the time zone that you want your VM to run into, your listener, so you can change the default ports that you want to use with your database, and then the tags. And then it will create the autonomous VM cluster. Now, unfortunately, on my infrastructure, I've hit the limit, but I can quickly pop into an existing a VM cluster that we've allocated, and you can see, so it'll give you kind of highlights of what is available within that VM cluster and what's already been allocated. Okay, so the next thing that we want to do then is look at the container database. So creating a container database, very similar again. One big thing there is if you're creating a container database, make sure your name is capitals. That took me a little while. And then base image. So you, again, what Robert had talked through, so you can actually have different software versions on your base image. So we'll leave that as that. Configuring the autonomous data guard. So with serverless, obviously you do it when you create the autonomous database. With the dedicated, we do it at the container database level, and we'll quickly just have a look through what is needed. Compartment, the display name, the region that you want to deploy it into, infrastructure again, the VM cluster, and then of course the protection mode. So if you maximum performance, just interesting here. So if you have maximum performance, you can set the lag that you want. If you don't, and you want maximum availability, you see that lag is not available there. For my container database, I'm not going to do it there. Similarly to the VM cluster, we can set the maintenance. So the same options that we had with the VM cluster, and we can also set the release update that we want allocated to this container database. And then just under the advanced options, Something that's important. So backup retention policy is set here, but also within serverless, you can set your encryption keys on the database, the autonomous database itself. With dedicated, it's actually set here. So you don't have the option when you create a database to change this key management. You have to do it at the container database level. And then that should be it. That will create a container database. Now, just quickly on the VM database, when that gets created, it takes a couple of hours, anything from 7 to 14 hours. With the container database, about half an hour. But then once the VM is set up and the container database is set up, creating autonomous databases is very similar to what you'll be familiar with serverless. And with that, I'm going to hand back to Robert.
All right, thanks, Quentin. Yeah, so that was a quick walkthrough, everybody. Let's see, I'm going to go back to the presentation. And I'm going to go desktop because I'm not sure. Okay, there we go. All right, so the thing that I wanted to emphasize is that when we talk about these VM clusters getting deployed on an infrastructure, so these infrastructures can run both of our services, the Exadata database service, or you stand up VMs of the autonomous database service. And there is a difference here, okay? And when you stand up the Exadata database service, the customer owns the VM. It's not Oracle managed, and so you could get into that VM and you could run anything you wanted. You could run WebLogic clusters. So we charge you as soon as you create a VM. So if you create a VM with 100 cores, we start billing you for 100 cores, okay? But for autonomous database, it's managed. You cannot get into it. The only thing that you can run are databases, okay? And so because of that, you're restricted to the API. We don't charge you anything to stand up the VM. So you could stand up a VM with hundreds of cores and there's no billing, okay? You can then come in and create containers. So, different containers that are just regular clustered or replicated and all that. And we don't charge you anything, again, for those containers, okay? We only charge you when you're actually running autonomous databases. So if you have a VM and a container that's got hundreds of cores, but the only thing you happen to be running, because you're just getting started, is one little database with 2 cores, that's all you're going to be billed. You're only going to be billed for those 2 cores. And if it's a developer database and you shut it down at night, well, then you're not getting billed at all, right? So you only get billed for what is actually running. And then it has all the additional auto scaling capabilities and all that you're probably familiar with autonomous database. And the whole point of that is it allows you to set up these governance environments. So what we call a fleet manager, somebody who's worried about the lower level components, can set up these VMs, can set up your dev test, UAT, prod, and it doesn't cost anything to put the governance model in place. And then all you do is you give quotas to different project teams and you make these environments visible. So now your developers, your application DBAs can come in and say one team, you've given them a quota of 10 cores, right? And so they can create databases and clone databases and delete them and run regression cycles on new fresh deployed instances, all within their quota. And another team might have a quota of 100 cores or something like that. And as long as they can do whatever they want, they operate within their quota that's assigned, okay? So you can set up this nice governance model and put yourself basically where you've got a private database as a service in place because it's dedicated to you, whether it's cloud customer or public cloud. You can set this up so that it's like your own private database as a service, and then just assign quotas and the teams get going on it. So it really helps to lower the total cost of ownership through more automation and operational delegation to Oracle. So this is where you move to fully managed services. It's our automation layers. It's our experts behind it, right? Because automation layers aren't absolutely perfect, right? So it's Oracle experts, and it's in a DevOps model. It's not regular support. So we've got thousands of little probes that we're going to talk about that are monitoring everything. And if anything goes wrong, we automatically are raising tickets into a DevOps queue. There's seasoned engineering guys that are basically getting in and dealing with anything that the automation layers might have missed. And so it's really, really solving problems fast for you. adding a bunch of automation that you normally get with autonomous database. So it really drives your cost down. So I want to just briefly cover some customer case studies of, what people are really doing in real life. This thing's been live now for, we're going on the 6th year. Okay. And so the kinds of things that customers are doing, and I've anonymized some of these things, right? It's hard to get very, very large customers, to be public references, for some of these things. You've seen probably some of the stories with Deutsche Bank and others, that are public about their use of autonomous database. But I want to, focus on some things that we're seeing in practice you might not have heard of. So, for example, this is a very, very large insurance company out of Europe who has basically created a cache, right? It's what they call a fast data platform using autonomous database. So what they've got a bunch of core transactional systems, like contractual systems, where they do all their insurance policies and all that stuff that they've had for a very, very long time, but they want to modernize. So what they've done is they've created data pipelines from those core systems using Golden Gate, and they're extracting real-time changes that are happening in those systems and bringing it into Oracle Cloud. And then they're staging that into the cloud using metadata layers, where they basically parse and add information into that core data that's coming out, and they partition it out into a bunch of streams using our Oracle Kubernetes clusters and Kafka pipelines. Okay. And so, and they then push all that stuff out into a bunch of autonomous databases. And then that's where they build all their modern apps. So all the new stuff that they're doing. So mobile apps, web apps, and there are some things that are in their own data centers, but they're also doing this multi-cloud. So they're deploying that new generation of apps in other cloud providers too, right? So in Google, in Amazon, and that's where all the modern stuff is then coming in and running on top of these autonomous database services. Okay. And just to give you an idea of what that fast data layer looks like, right? It's taking all that like contract stuff, all the property and casualty, all the regular, customer oriented stuff, bringing it out and fronting the modern home insurance apps, their advanced analytics, their e-commerce, their workforce management, real-time reporting for their operations. All that stuff is getting built on the front end of this autonomous database layers. And they're really, really super happy with this. So they've also introduced a whole analytics layer that I'm not even talking about here, right? It's a whole alternate layer that's doing all their 360 sort of customer analysis and all that, and building in all their AI stuff, right? Another one that I wanted to talk about, this is a company who, again, Oracle data services layer. They built one of these data services layer. And this is like what I described to you. So what this company has done, and they're a big energy provider. So you could think of them as somebody who builds platforms basically that help with energy. Okay. And so they had a bunch of data centers, and they wanted to get out of those data centers. And so what they did is they took all the databases that were running in those data centers, and they staged all the information out to object storage, and then pulled the information off of our object storage into a new set of autonomous databases in the Oracle Cloud. Okay. But in that process, they set up exactly what I described to you, that governance layer. They've got a dev test, they've got a stage environment, they've got actual, QA, they've got 4 environments in prod, and they basically have moved everything into this environment. And they've also ported their applications out of their data centers. And in this case, they put it in Azure. Okay. So it's a multi-cloud environment. And, the new stuff that they build is in Azure, again, operating over this layer. But they have this governance model in place where all changes go in through the dev test, eventually graduate into UAT, and finally hit their production, because they've got a lot of very mission critical stuff. There's some SAP stuff and other very important apps that they're running their business on, right? Okay. And then a last example is it was a company called Alliance Data Systems. They recently rebranded themselves to Bread Financial. But here's a classic case, right? So this is a customer who they were running Oracle on-prem on Exadatas. Okay. They moved off of on-prem into Oracle Cloud, and they first went to the Exadata database services. So they were, and it's a PeopleSoft app. So that's it's an Oracle app, very important to them, running now PeopleSoft in the cloud on Exadata database service. But they kept hearing about this autonomous database. It'll drive my costs down even more. And so they said, hey, we want to get on this autonomous database stuff. So they migrated then to autonomous database on dedicated infrastructure. Okay, so now their PeopleSoft is running on autonomous, and they characterized what they got, what the benefit was from that. And it was across the board, right? They got huge performance gains because they hadn't taken the time to really understand, the details of how to use Resource Manager and all that stuff in the Exadata database services. And when they moved to autonomous, it's like all of a sudden the whole architecture there, they're just connecting through the services. They've automatically got this degree of parallelism that's happening. All their analytics side of the PeopleSoft stuff is all accelerated. They get this better performance. And at the same time, they were driving down their costs because all these administrative tasks they had to worry about before, where they had to control the patching and all that. They didn't have to do it anymore, right? So all the backup stuff was just automatically happening. And so they said basically they're saving sort of 60 to 80 hours per quarter in just managing databases. So overall, they've saved a lot of money, and they're very, very happy with this, full-on mission critical, autonomous data guard replicated across region deployment of PeopleSoft, right? So even Oracle apps, and it's all of them, Siebel, even EBS these days is our enterprise business suite is available. So now I'm going to turn it over to Germán Viscuso from my team, who's going to start talking about the observability topic, because most customers who are deploying very advanced things, they don't want to treat this as a black box. Yeah, they want Oracle to operate this database, right? Our experts doing it, but they want to know what's going on. So Germán is going to talk about how that is achieved with autonomous database. So Germán, go ahead and take it over.
Okay, thank you, Robert. All right, so let's talk about observability. When people hear about database observability, they often correlate it to database monitoring. That's the first thing that comes to mind, but this is just a part of database observability. Database observability is an ongoing cycle where first telemetry is collected, for example, performance metrics coming from the database, then processed as part of a database monitoring, for example, collecting this information in the OCI monitoring service, which I will talk about later. And then there are internal things analyzed, like, for example, the queries or internal processes within the database. Finally, there's a database tuning step where the customer progressively tries to, fine-tune the database to make it better and better. So this happens in a constant cycle. So as you can see in yellow in the screen, for managed services like Autonomous, Oracle also takes part in the observability cycle with the potential to react to anomalous situations. So for example, Oracle Ops could do a fix on some specific issue without the customer intervention. So we will cover this in a deeper way later. So there are, of course, things that we would expect customers to own, right? So what you see here is the ADB's responsibility model. And I have singled out that the monitoring of the application, the health of the application performance, the queries and the updates of the applications running on top of the database, that's something that belongs to the customer. So you have to, work optimizing that. However, we provide all the tools and services for you to effectively do that. And we also support interface into third-party observability tools in case you want to, connect and correlate these activities with other tools that are not living within OCI. So let's take a closer look at that. As you can see here, you can see multiple things here, but basically we provide performance and scalability tools, both as part of the UI when you go to the OCI console, for example, Performance Hub, and also via standalone software, like for example, Enterprise Manager, which fully supports autonomous database. We also provide APIs for every single event, for every metric, for every log that you can access. We have high availability features, a lot of capacity planning dashboards that you can tap into, and also a lot of fleet management functionality. We work very hard to support multiple observability scenarios, and we base that on feedback coming from our customers. And we also work closely with the observability and management platform team. That's why we had that last item in the poll. because we want to make sure that ADB is a first-class citizen in Oracle's offering related to observability. All right, so let's go back to the responsibility model. Now I have signaled out other two things here. Take a look at monitoring service health and alerts and notifications. As you can see here, Oracle is responsible for monitoring the autonomous database service health and sending all the alerts and the notification and multiple levels of the database stack. We are not only exposing these observability insights to you, but we are also reacting independently to it. And I will go deeper on that later. So when I discuss database observability, the cycle, specifically I mentioned how Oracle Ops incident response is working on behalf of our customers. So we are bringing all of our expertise and machine learning technology to do consolidating monitoring of the entire database stack. Automatic SRs are generated when there's a deviation, and we also do root cause analysis if there's any issue. And even if you file in your own SR or customers filing their own SRs, we have a faster response thanks to all the contextual information that is gathered by the services and provided by the service. So when we combine all of this with, for example, autonomous data guard, we can give customers a 99.995 SLA guarantee with no ridiculous exclusions. So I mentioned support for alerts and notifications as part of the responsibility model, right? So you need events happening to generate them. So an event is basically something that informs of a resource state change. And this happens all across OCI with every single resource, right? So for ADB on dedicated infrastructure specifically, we have two types of event. We have control plane events and we have data plane events. So control plane events are events that are generated via the use of published APIs by customers, such as starting a backup, to give you an example. While on the other hand, data plane events are events that were triggered within the database or on the host to a specific issue happening within the database. For example, automatic failover because there was a primary failure, to give you an example. So every time Oracle Ops is acting on an incident, you can get the corresponding critical event and set some rules to perform operations if needed. And this can happen not only for critical events, for every single type of event. There are an example there in the middle bullet that it's interesting, which is uploading a file when there's updating the database or migrating the data when there's a file uploaded to object storage. So these events can also be integrated with third-party services like Slack, PagerDuty, etc. Here's a quick snapshot of the events you can subscribe to at multiple levels of the database stack. This is what Robert covered when he showed the resource model, okay, of autonomous database dedicated. So as you can see, you have multiple events being fired at all levels of the database stack, starting from the Exadata infrastructure all the way to the actual instance. But we also have autonomous data guard associations, which are important because this is unique to autonomous dedicated. You will also see here multiple critical events that you can subscribe to. So let's take a closer look at how Oracle Ops is working behind the curtains, because we've been mentioning that Oracle Ops is working on your behalf behind the curtains, but what is exactly happening here? So for those issues that are not solved automatically, as Robert already mentioned, we have our ops teams getting all the alerts, control plane and data plane event alerts, and they are a matching Jira ticket is being generated and it's put in a priority queue that's monitored 24/7. So the team then responds on a per severity basis over this queue, and obviously complying to specific SLOs, because different kind of severities, different kind of issues have different type of SLO requirements. So that's also taken into account. And here are a couple of examples of data plane events and control plane events. For example, typical data plane event would be with the the Exadata infrastructure issues, or also control plane events. In this case, you have an event generated when you create a database. For example, you create a database, and then you get an event generated for that. All right. So now let's see events in action. I pass it back to Quentin from the EMEA ADB specialist team, who will show you an events demo. Quentin, thanks.
Thanks, Herman. Okay, so what I'm going to do now is quickly set up a a notification based on some of the events that Herman has talked through. So the first part that we want to do is we want to set up a notification. So we pick notifications as part of the application integration. You see we already have some in there. We create a topic and we call our topic restart. So what we want to do is we want this event to fire when we restart a container database, as you'll see in Alastair's demo at the end of the presentations. We do a create. That will be created, and then we can create a subscription underneath that. So a subscription would be what you want this to event out as, whether it's an email, a function, a URL, pager, even out to Slack or SMS. In our case, we want to use an email, and I've set up an email address out for us. Now, what we'll get once we look at that email address is we should have a confirmation email. So we click on that to make sure that that is set. And then if we pop back into the notification, so we've set up that now. So the next thing we want to do is to then create the actual event. So it is under the rules that we have within the event service, and we create a rule. So call our rule restart, for want of a better word. The event type. So the condition that we have here is event type. The service name would be database service. And then under the event types, you will see all of those events that Herman had described already. So control plane events like terminate, start, and then of course the critical events. So if you have an alarm set up on the metrics on your database, it'll be fired as a critical event. In our case, what we want to do is we want to set that when we click a restart on our container database. You can go in and you can validate this rule if you want to. So see, that's all okay in there. And then the action. So if this event happens, what do you want to happen? We have three choices within this. Streaming, which is to our pub sub or a messaging service where you can subscribe to those topics and you can use them. With functions as well. So if you have pieces of code that you want to fire whenever one of these events happen, and then notifications, which is just a notification that we've just set up. We go in here and we pick our notification that we've just set up, and you'll see restart is in there. And then that will create the rule. Now we're not done yet. You see the event is in there, but we need to have an attribute. So we need this to fire when something happens within our container database. So the thing we'll do is we'll pop into the container database. We grab the OCID of that container database. We come in, container database ID. We add that value and we add the attribute. And that's it. Essentially what we've now done is we've set up the notification to fire when we restart that database. And we'll see that again, like I said, with Alastair's demo at the end. Back to you, Herman.
Okay, great stuff. Thank you, Quentin, for showing us that. So let's keep going.
Hey, let me just comment too that you can group a bunch of those events together. So, for example, that rule that you saw Quentin creating, you could put for every resource class, you could create one rule that says, give me the critical events for the infrastructure, for the VMs, for the containers, for the databases themselves, you know, and then you can have a group of people who are behind one of those notifications that if anything critical happens to any resources, they're going to get notices about that, right? so these are it's about grouping things together. So, if you have people who are interested in auditing, for example, you could create one topic where for example, whenever backup events happen, it creates a record that backups happen, so that the people who are auditing can take that to their auditors and say, look, here's my evidence that backups are happening properly, right? So you can group these things together, so and aggregate lots of those little event types into one rule. Okay, so I just wanted to make sure it was clear.
Yeah, great. Thank you, Robert. All right, so let's move on. So events are asynchronous, so they fire in specific situations, but we also accumulate metrics periodically to help our customers with database observability. So we work closely with customers to understand what type of metrics they need exposed in order to do their observability processes. And this is important because different customers have specific requirements. Here you can see how we expose, for example, apply lag and transport lag as part of Autonomous Data Guard. So these metrics are updated frequently on regular intervals, and we usually refer to this interval as the interval granularity of the metric. But these are only two metrics. We export a rich set of metrics to the OCI monitoring service. And the OCI monitoring service, if you're not familiar, is the system within OCI responsible for collecting all the metrics that the resources are generating in the OCI platform, not only ADB metrics. So here is a list of metrics that ADB-D exposes. Take a look at how you can use metrics like CPU utilization, for example, to set up your own alarms, or you might want to do a certain automation depending on what's happening to sessions, for example. You can track sessions via that metric. And you can also use a lot of the storage related metrics, as you can see there, if your workload is critical on that site and you really want to be monitoring all the metrics related to storage. So with ADB-D, you get the deepest metrics for an autonomous database, such as I/O throughput, for example, transport lag, apply lag, as I already mentioned. All right. So here's a quick overview of the OCI monitoring service, just to give you a big picture of the service. It's a fundamental building block of the observability and management platform, together with the OCI login service. So this is like a centralized aggregator of what's going on with the database and other services, obviously. It supports a rule trigger system, and it has many ways to interface to third-party systems. So it can be a great ally for setting up observability processes. You could send to Slack, PagerDuty, you have SDK support, OCI console support, etc., etc. So this is not isolated within OCI, but it's basically a great tool that you can also interface with multiple systems. Now we're going to do a demo courtesy of Alastair, another member of the EMEA ADB specialist team. Here we'll see an app workflow similar to a customer experience that is unique to a dedicated environment and shows some maintenance activities. So Alastair, all yours.
Thank you very much, Herman. Let me just share my screen. Okay, so we've seen a lot of information. You've had a lot to pick up in a very short time. And we did have a question in chat earlier about what happens at 24/7 operations. And that's a really excellent question. We've seen how we can have virtual machines spread across clusters. We have a lot of control over what we can do with a dedicated environment. But this is a very important factor, is that as we have more databases consolidated onto an environment, then we have to have some way to manage and operate that environment without having to try to negotiate amongst all the application owners when we're going to have an outage. So one of the technologies that's part of the Oracle database and ecosystem is transparent application continuity. And we use that to allow you to do graceful operations without interrupting the user experience. So I'll just briefly explain this slide what's going to happen. What I'm going to do is demonstrate what happens when we have a patching cycle. I'm going to run an application. That's a little window shot of it in the top of the screen there. And what we'll see is we'll start with a steady state, which is where we have a number of, let's get the laser pointer there. We'll start in this steady state here, and we'll see both servers in this cluster. We've got 2-node cluster, both servers running. What we're going to do is initiate the process of patching, and we'll see a graceful switchover. What will happen is the users will be directed to one of the nodes. In this case, it'll be node 2, and node 1 is gradually emptied of users. When that's being completed, then we can do our operations on node 1 while the load continues on node 2. Once the operations on node 1 is finished, that'll be restarted, and then we'll reverse the process. We'll move the users from node 2 back onto node 1, and then do the operations on node 2. And then when we get to the end of this process, we'll see that we'll be back into the steady state where the users can use both of the nodes. So that's a cycle we're going to go through. And through this, we'll see there's no outage for the application itself. Just one point in passing, I've kept this diagram simple by having just 2 nodes. But if you have 3, 4, 5, 6, 8 nodes, then this process will roll through the nodes in the cluster, starting with 1, 2, 3, 4, and so on, so that you'll see that rolling process going on. Well, let's just take a look at that process now. Here I have the application. I'm using a small test application called Swing Bench. This has been running for a few minutes. There's something else I'm doing here is I've actually overloaded my autonomous database. So we should see the alerts that Quentin set up earlier telling us that our database is overloaded. So what I'm doing here is I'm running the database in a highly overloaded and not good operations, but useful for the sake of this demonstration. So we've got the database running there. I've got a couple of charts here just to show us where things are running. Just refresh the charts. And on this corner is the one that's really worth watching. And this just shows us which node or instance in the cluster is running the application users. That's these users up here that you can see there. And then there's, if you just look at this, you'll see there's some other information about what's going on. But this is the one to focus on. I'll just move up to my screen here. Let's just do a little refresh on that. So we've got some charts here. Where I am, let me explain where I am. I'm looking at my autonomous database interface. There's useful little charts here that shows. There's useful little chart here that shows how the capacity is being used, and a very good summary. And what I'm seeing here is that I'm starting to load this machine. We haven't quite seen the metrics pass through yet. Just to refresh on that. And you see there, I've got a high load running on this machine. So what I'm going to do, while we've got this high load running, I'm going to go through a maintenance cycle. I'm going to emulate patching by restarting my container database. It'll go through exactly the same cycle as you do with patching, with the rolling start and stop. This is the container database I'm using. And in this container, you'll see there are a number of databases. And this is actually my demonstration database here. And what I'm going to do is restart the container. So by restarting the container, I've now initiated that process of going from node 1 to node 2, and then doing the maintenance and back again. And what we should see in the next few moments in the application here is there'll be a short interruption to the performance just as it goes through the switching phase. We'll just see in a moment. And what I expect to see is this will happen very quickly. What happens with the application continuity is we have a timeout period, a drain period, where you can gracefully switch from one node to another. At the end of a transaction, your next transaction, there we can just see it happening there. At the end of your transaction, your next transaction will occur on one of the other nodes. And just look at it. You can see now, actually, we've switched everything very rapidly. Now, that's because my transactions are happening very fast. Now, if you happen to be in a situation where you have long-running transactions that were lasting over 5 minutes, at the end of that period, transparent, the application continuity part kicks in, where that connection and sessions moved over to one of the other nodes, and your transaction will be replayed. So you don't have to do any work to continue your application running. And an important factor there is that I've not made any change to this application so that I can do this rolling operations. So I think that's a very important point to make. So you aren't going to have to instrument your applications. This is instrumented into the Oracle infrastructure. So we've seen that change there. I'm going to go and check what's happening in my email. Let me just see, we're going through the restarting phase. And we can see there are two things. There was an event here that told me that my CPU was overloaded. So that was the one you saw Quentin was setting up earlier. And I think at the top here, we're seeing another notification, and it might be a little bit small to read, but embedded in that XML, that's telling us that we've gone through this restart process. So you can see there that those notifications that were set up and went through the messaging environment have arrived in email to alert me that something has happened. Okay, so just to summarize, we saw here that the application continued running. There's a little bit of a drop just as the sessions reconnected to the other side, although the application load didn't completely stop, and the operations have continued. And we saw here how we moved from instance 1 to instance 2. This will take about another 3 or 4 minutes before we get the switch back to instance 1. So I'm now going to hand back to, I think Robert's going to pick up from me here.
Yes. Hey, thank you, Alastair. A great demo. And I think the main point of this is to highlight that autonomous database is designed in such a way that that these both planned and unplanned activities can be performed in such a way that they have minimal impact to the running applications. And so that was the whole point. And the whole, so this whole idea that you could set up these different sort of policies on these different resources to monitor what's going on and to control, so that your software updates go in through a particular dev test environment before they eventually get promoted into prod, is important because our customers run a whole spectrum of databases, and some of them are very simple, some of them are interdepartmental. They're important, but they're not like running your business. But when you start to get to these business critical, mission critical applications that are driving your revenue, you want more observability. You want the experts of Oracle to manage these database services on your behalf, but you want to be able to hook in. And that's what the point of this session was, to show you how to hook in so that you can see what's going on behind the curtain. So you can put this kind of trust and verify oversight in place, so that, because software is it's not perfect, right? So you want validation that autonomous is living up to that promise, right? And so when you set up these governance models and let all change propagate through one layer and then eventually get promoted to the other, you're giving an opportunity to validate that autonomous is doing exactly what we are saying it's supposed to do. And if for whatever reason there's some software or some hardware related failure or some kind of issue going on, that you're hooked into that cycle, and you've got observability, that we're aware of it, that we're responding. You don't have to go through this old support model of filing an SR and waiting for somebody to get back to you and then getting more logs. You don't have to do any of that. It's a DevOps model, and it's just going to happen. Our automation layers will respond to all this stuff oftentimes, and if the automation stuff can't do it, our experts are there basically to make it happen for you. Hopefully that gives you a great idea about the additional controls that you've got with a dedicated environment, and a little sneak peek into how it is that the database system operates and how you can exercise those controls yourself to test your own applications to make sure they're behaving well for any unplanned and planned event. And so with that, there are a bunch of useful resources, and I think I'll turn this back over to Tom to take us through the rest of this content and come to a close.
Thanks, Robert, and thank you. Great demo, by the way. And I just want to say, Robert, thanks for presenting here. It's 2 a.m. where Robert is, so it's a miracle he's actually able to talk and go here instead.
Happy to do it. Thank you, Tom.
Appreciate it. Okay, I'll keep this short and sweet and to the point. I will close this call. So thank you all, and I'll talk to you all and see you on the next one. Have a great day. Look after yourselves.